Hey everyone, Morgan here. So we're back still talking about lattice energies, page 18 of the bonding outline for AP Chem. And in question number 3, you're going to notice right away I did not give you equations. I gave you names. And this is an effort on my part to help you get used to writing thermochemical equations on your own. So we want to calculate the lattice energy for MgO from this following data. So Mg2 plus gas plus O2 minus gas goes to MgO solid. That's our goal equation. Lattice energy is the energy released when two gaseous ions come together to form an ionic solid. So we're going to need Mg2 plus gas as one of our first reactants. Okay, I can actually get that from the ionization energy, well, the reverse ionization energy. Mg2 plus gas plus 2 electrons gives me Mg gas. Now, since the ionization energy is 2188, this actual energy will be negative 2188, and these will all be kilojoules per mole. Okay? I'm also going to need O2 minus gas, which I can get here by looking for, let's call that the electron affinity for O. So O2 minus gas goes to O gas plus 2 electrons. Now, that's the reverse of electron affinity, because electron affinity is the energy released when you add electrons. So in this case, instead of 737, it will be negative 737 kilojoules per mole. Okay, so now I've got my two reactants. The next thing I need is my product, which is MgO solid. That'll come from the heat of formation. Mg solid plus 1/2 O2 gas gives me MgO solid, and that heat of formation is negative 602 kilojoules per mole. Okay. So now I just need to get rid of some stuff. Okay. How about the magnesium gas, the magnesium solid? I can do that with the heat of sublimation. I want Mg gas as a reactant, Mg solid as a product. That's the reverse of sublimation, so this will be negative 150 kilojoules per mole. And then bond energy for oxygen will help me. I am going to go with 2O gas to give me O2 gas, and I'm going to multiply this whole thing by 1/2. So when I take the negative 498, because I reversed the equation there in the definition, kilojoules per mole, I'm going to multiply that by 1/2. All right. Mg gas and Mg gas cancels. 2 electrons and 2 electrons cancel. Okay. Mg solid and Mg solid, that cancels. Okay. Now I've got 1/2 O2 gas. We'll cancel my 1/2 O2 gas. Boom. Boom. Actually, no. Yeah, that's good. And then O gas and O gas are both going to cancel. And the only thing that I'm seeing now that's left is Mg2 plus gas plus O2 minus gas. There and there, all the others have canceled out, to give me MgO solid, which is what I was looking for. And when I add all of this up, my calculator tells me negative 3926 kilojoules per mole. All right, there you go. So we have to get good at taking these names and converting them into equations. All right, this time, instead of looking for the lattice energy, we'll look for the heat of formation for KCl. Let's see, that would be K solid plus 1/2 Cl2 gas to give me KCl solid. Now remember, heat of formation is the energy released when 1 mole of a substance is formed from its elements in their natural states, which means I am allowed to balance with some fractions there. Okay, so I need K solid. That's the first thing. We'll get that from ding, 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 ding. How about enthalpy of sublimation for potassium? K solid turns into K gas. Delta H naught equals 64 kilojoules per mole. Don't need to change the sign because that is actually what the definition is. Solid to gases, sublimation. Okay. Then to get rid of this K gas, what I'm going to do is I'm going to take K gas goes to K plus gas plus an electron. That's the ionization energy for K. And that's 419 kilojoules per mole. I need some Cl2 gas. Okay. So I'm going to get that based off the bond energy for Cl2. Okay. Cl2 gas goes to Cl gas, and I'm going to multiply that by 1/2. So then my value here of 239 kilojoules per mole, I'm going to multiply by 1/2. Now, let's see, electron affinity for Cl. That is the Cl gas plus an electron goes to Cl minus gas. Okay, that's cool. Now that one, 349, it's negative. I haven't changed it, so this is negative 349 kilojoules per mole. Now, the last thing that I have, which I need to use to get KCl here, that is the lattice energy. And the lattice energy is K plus gas plus Cl minus gas gives me KCl solid. That lattice energy is negative 690 kilojoules per mole. I didn't reverse it, so I don't have to change the sign or anything. K gas is going to cancel. K plus gas, okay, and the electrons are going to cancel. That's nice. Okay, K plus gas and K plus gas are going to be gone. The Cl minus and the Cl minus are going to be gone. Okay, and now the Cl gas and Cl gas are going to be gone. Wow, it looks like the only thing left now is K solid plus 1/2 Cl2 gas to give me KCl solid, which is, hey, the heat of formation. Equals, add that whole thing up, and I get negative 436.5 kilojoules per mole. There we go. All right, so that and page 17 and 16 before this show you quite a bit about working with lattice energy. And please be aware that more than anything, we just need to understand what it is and what it represents. There's not going to be a ton of math problems dealing with it, but there'll be a lot of questions about explaining things like melting points and boiling points that we use this for. All right, thanks for tuning in. This is Morgan, signing off.